Introduction: Recursion and Loops in Programming.
Understanding when to use recursion or loops is essential for efficient problem-solving in coding. Both are tools for repeating actions, but their best use cases differ. Let's explore what makes recursion and loops unique, and discover practical examples that show the ideal choice for each approach.
How loops work: straightforward repetition.
Loops, like for and while, are ideal for tasks with a clear, repeatable process, or when the number of repetitions is known. They offer a simple way to iterate over data structures, such as arrays. For instance, summing the elements of a list or printing numbers from 1 to 10 is typically done with a loop due to clarity and efficiency.
Recursion explained: breaking down complex problems.
Recursion occurs when a function calls itself to solve a problem by breaking it into smaller, similar subproblems. This approach is especially suited for problems defined by self-similarity, such as traversing tree structures, computing factorials, or solving the Fibonacci sequence. Recursion can make code more elegant and easier to understand for these complex, nested tasks.
Choosing loops: best scenarios and advantages.
Loops are best when tasks are simple, don't involve deeply nested structures, or require high efficiency. They use less memory and avoid the risk of stack overflow, which can occur if recursion is too deep. Examples include iterating through arrays, processing lists, or executing code a fixed number of times. Loops are usually easier to trace and debug.
Preferring recursion: when it shines.
Recursion is preferable when the problem itself is recursive or involves branching into multiple subproblems, like parsing nested objects or evaluating mathematical expressions. Tasks like directory traversal, tree searching, and backtracking algorithms often benefit from recursion. It helps make complex solutions readable, although it may be less efficient than loops for simple repetition.
Summary: making the right choice.
Use loops for simple repetitive tasks and when you know how many times to repeat an action. Choose recursion for problems involving hierarchical or self-similar structures. Always consider readability, maintainability, and performance when deciding. The right choice leads to clearer, more efficient code tailored to your specific problem.